Yeah, let's continue. Question number 7 of the question paper. Let's move on. This is acid and base question. 18 marks are for grabs. Let's see whether we can answer all these questions here with our understanding. They say in 7.1, on this one, they say a standard solution, remember standard solution is the solution of known concentration. A standard solution is prepared by dissolving 10 grams of sodium carbonate. Formula is given there in 0.7 dm cube of water. Calculate the concentration of the solution. Best, there are two options. Option number 1. Option 1. I can combine the two to say C equals to M over MV, which would be, I will have option 2 here. So mass is 10. Divide by the molar mass of sodium carbonate, it will be 106 multiplied by 0.7. The answer gives us 0.135 mole per dm cube. And the option number 2, which is the best option in my case, then this one says you start with the number of moles of sodium carbonate, which will be given mass over the molar mass. This one gives you 10 divided by 106. Gives 0.094 mole. Then now with mole I can find concentration, which will be the same as 0.094 divided by 0.7. Therefore you get the same 0.135 mole. Yeah, that is the second option. Now 7.1.2, let's check. They say, will the pH of the solution be greater than or less than 7? According to this one, then now we know, since sodium carbonate is a base, therefore the solution, the pH must be greater than 7. Then your answer would be greater than 7.1.3. Now explain. You write an equation that explains the answer to question 7.1.2, because we know, and let me just try to explain and not be academic on this one. Firstly, you need to ionize the sodium carbonate. There's no mark for that. Sodium carbonate will form sodium ion plus carbonate ion. Carbonate ion is fine, 2 sodium ions. Thank you. And then now we are going to analyze these 2 ions. Say, remember, there's a rule in hydrolysis that only a strong conjugate acids or bases undergoes hydrolysis. Only strong conjugate acids or bases undergo hydrolysis. Where do you get strong conjugates? They are normally coming from weak acids. Therefore, this one is coming weak acid or weak base, meaning that the ions of weak acids and weak base undergo hydrolysis, but those of strong ones, they don't. Like here, sodium ion is coming from sodium hydroxide, which is strong. This is weak. therefore no hydrolysis here. And this one is coming from a weak acid, carbonic acid, therefore this conjugate is strong. That's the case. Fine. Then the carbonate now will react with water to form, because this one is a conjugate base of the acid, it will accept, conjugate base will accept the hydrogen proton in this case, and then leave water with OH minus. Now we are going to now make a conclusion on this one. Yeah, you can see this is the equation that they wanted you to write if you were knowledgeable of what happened before. You just have to write this equation. Then there's no need for this one, but as a maybe explanation to main learners, you can start this way and then so you come this one. We're not going to penalize you from starting with this one. Thank you. 7.1.4. Now they tell us to say the sodium carbonate solution is titrated with dilute hydrochloric acid. The following indicators are available for this titration. Fine. Sodium carbonate is a weak base and a strong acid. Therefore, it will be slightly acidic, below 7. Therefore, which one of the indicators PQR is the most suitable one? So because it's less than 7, then obviously it will be P. And then for this titration, give reason for the answer. And just say now it's this one, weak acid titration of weak base and strong acid. Strong acid in that case. Or I hope they can accept when they say the pH will be less than 7, or if they say solution will be slightly acidic, because the pH will be below 7.2. Let's go and see 7.2.1. When 0.01 moles of dilute sulfuric acid is mixed with 0.024 of potassium hydroxide, strong, find the total volume of the final solution is 0.2. Find what is meant by dilute acid. We've got concentrated and dilute acid. Therefore, the dilute acid will be the acid that contain or consists of small amount of acid in proportion to the volume of water. In proportion to the volume of water. Very important, that one. To the volume of water. That's the case. That is your dilute acid. It's about the volume of water in that solution. Now let's come to the next stop, which is our 7.2.2, the penultimate. 7.2.2. Now when we read the question, they say calculate the pH of the final solution. Like this one, the moles are given. If the moles are given, then what we need to do first is just to calculate which one is limiting between the two. Therefore, we just number of mole of sulfuric acid. Number of mole of sulfuric acid will be the same as 0.01. You divide by the ratio, mole ratio in the equation, you get 0.01 mole, and then whereas number of mole of potassium hydroxide will be 0.024 divided by 2. Remember, the 0.024 is given here. Divide by the 2, which is the coefficient, then we get 0.012 mole. Now we compare the two, 10 and 12, which one is smaller? Then we know that now, therefore sulfuric acid is limiting. HSO4 is limiting. It's a limiting reagent. Fine. If sulfuric acid is limiting, means that potassium hydroxide is in excess. But by how many moles? Then let's calculate the excess moles. The excess moles in this case will be 0.024. According to this one now, if you look at the reaction, this one will be used completely, that's 0.01. Then we'll have this one 0.01. It will be now the 2 times 0.01, which give us how much? 0.004 mole. Fine. In this case now we'll calculate the concentration of the excess moles. Fine. Excess moles, it will give us number of mole over volume, which is 0.004 divided by 0.2, which give us in this case 0.02 mole per dm cube. Now, according to this one, they say, oh fine, the concentration of OH minus is the same as the concentration of potassium hydroxide, which will be the same as 0.02 mole per dm cube. Because we want the pH, now we use the Kw, concentration of hydronium ions, multiplied by that of OH minus, will give us 1 by 10 to exponent minus 14. Therefore, the concentration of hydronium ions multiplied by 0.02 equals 1 by 10 to exponent minus 14. Concentration of hydronium ions will be the same as 5 by 10 to exponent minus 13 mole per dm cube. Then finally the pH will be minus log of concentration of hydronium ions, which will be the same as minus log of 5 by 10 to exponent minus 13. Therefore, the final answer will be 12,3. That is the final answer for this question. Hopefully